Hello and welcome to Mr. Tompkins EdTech and my series of walkthroughs for the AQA GCSE Mathematics past papers. This particular video is June 2017, Paper 3, Foundation Tier. Now, with the new specification being new, Grade 9 to 1 past papers are like gold dust and you should not be watching this video unless you've already attempted the paper yourself under test-like conditions. If you haven't, stop the video now and go and do it first. I'm serious, go. Still watching? That's great. Why not subscribe to my channel so you can easily find it again the next time you want some help with your maths. I have plenty of A-level content too, so make sure you come back and check that out if you're carrying on with your maths next year. Please hit the like button if you found the walkthrough helpful. This really helps out my channel and it makes it much easier for others to wade through all the YouTube dross and find the good stuff. Also, before attempting the actual past papers, make sure you've gone through all the practice sets first. AQA produced 4 sets of practice papers to help students prepare for the new GCSE exams, and I would advise you to work through these before moving on to the actual past papers. Have a look at this video series which gives full walkthroughs for AQA practice sets 1 to 4. If you don't happen to have a copy yourself, you'll find a download link to the practice paper in the description below each video. Finally, feel free to ask questions below. It would be helpful if you include a question number and be as specific as possible. I really appreciate your comments and feedback and I try to respond to these as quickly as I can, especially around exam times. Okay, let's get into it. Question 1. Circle the lowest of these temperatures. Well, the lowest one is going to be the most negative, and the most negative is -7. So it's that one. Question 2. Circle the expression that is 4 times bigger than n. Well, n plus 4 is 4 more than n. That's not quite the same thing. 4n is 4 times n. That's the one we want. Let's just check the others. N divided by 4. No, that isn't it. And n to the power of 4 is n times itself 4 times. So that's not it either. So 4n is the one we want. Question 3, circle the fraction greater than 3/10. Okay, well, probably the easiest way to compare fractions is to convert them all into decimals. So you can tap each one in turn into your calculator and write it down as a decimal if you don't know what they are already. Okay, pulling up a calculator. If I type in 1 divided by 3 equals, you see it writes as a fraction, but then I can use the symbolic to decimal button, which is this one. That converts it into a decimal number. Now that's 0.3 with a dot on the top, which is the same thing as 0.3333 reoccurring. So I'm going to write that down as 0.33. I'm just going to write down the first 2 digits of these numbers so I can compare them. Okay, next one is 3 divided by 11. 3 divided by 11, or 3/11, is 0.27 with 2 dots, which is 0.272727. Let's just write down the first 2 digits of that. The next one, 4/15. 4 divided by 15. That gives me 0.26 with a dot on the top. So that's 0.266 reoccurring. And then finally 29 over 100. Well, I know that one off the top of my head. It's 0.29, isn't it? Okay, so which is greater than 3/10? 3/10 as a decimal is 0.3 or 0.30. So the one that's bigger is that one there, the third. All the others are smaller. Question 4. Circle the value that is 2 to the power of 5. Now 2 to the power of 5 is 2 times 2 times 2 times 2 times 2. So when you times 2, you double it, don't you? So 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. Okay, alternatively, you could pull up a calculator and type in 2 and use the power button, which is this one, and put in 2 to the power of 5. Either way, you're going to get 32. Okay, question 5. Simplify a times a times a plus b plus b. Okay, so we've got a multiplied by itself 3 times. So that's going to give me a cubed, and I've got b plus b, so b added to itself. B plus b is 2b, and these two things are added together, so it's going to simplify to a cubed plus 2b. 5b says simplify 5 open brackets x plus 3 minus 3 plus 2. Okay, so I'm going to multiply out this bracket. When I do, I'm going to multiply everything inside the bracket with the 5. So first I'm going to multiply the x by 5, and then I'm going to multiply the 3 by 5. So that's going to give me 5x plus 5 times 3 is 15. Okay, now I've still got my minus x plus 2 that we had up here. It's still going to be on the end here, isn't it? And this gives me this bit here. Now it's a matter of collecting like terms. Okay, so I've got 5x minus x. 5x minus x is 4x. And I've got 15 plus 2. And 15 plus 2 is 17. So the final answer is 4x plus 17. Question 6. 12 cards numbered 1 to 12 are put into 6 pairs. Each pair has a total. Complete the table to show the pairs and their total. Okay, so the first one's been given, and we've been told that is 1 and 2, and that totals to 3. So we've got the remaining 10 cards to put into the pairs. Okay, let's just write out what we've got. So card 1 and card 2 have gone. So we've still got card 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12 to place. Okay, let's just make that a bit smaller so we can see all of them at once. Right, so how are we going to fit these in? Well, probably it's a good idea to start at the extremes because there will be fewer ways of making those numbers. Let's have a look at this 22 down here. Now, I can only make 22 with 2 large numbers, can't I? So if I have the 12 in it, then I'm going to also need the 10 to add up to 22, aren't I? So those two have now gone. I can't use the 11 because there isn't another 11 to give me. Okay, next one. Let's just see if we can then find some other pairs like that we can rule out. Let's try the other end. Looking at the 9 down here. How can I make 9? Now I could make 9 in 2 different ways. I could have the 3 and the 6, or I could have the 5 and the 4. So I'm not quite sure what to put there yet. Let's have a look at the other end then, the 19. How can I make 19? Okay, well I've still got my 11, and I could use the 8 and the 11 to make 19. Is there another way of making 19? If I use the 9, and 9 and 8 isn't enough, 9 and 7 isn't enough, no, there's only one way of doing it, it's just those two, isn't it? So if I can use the 11 and the 8 then, those two went together. Let me write those in. So 8 and 11, now they've gone, that makes 19. 14, what pair is going to make 14? I could use the 9 and the 5, that's a possibility. Can I use the 7 and anything? Nope, 7 and 6 makes 13, and everything else is lower than that. So it's going to have to be the 9 with the 5. So 5 and 9 go in there. Next one, 11. What can I make 11 with? I've got my 7 left. I could use the 7 and the 4. That makes 11. Can I make 11 with 6 and anything that's left? Nope. So it's just those two then, isn't it? So I can pair those two up. 7 goes with 4. 4 and 7. And that leaves me with 3 and 6, making the 9. Okay. So the technique there was just start at the one of the extreme ends, which is difficult to make with the other numbers, and then kind of work backwards. I think we've done. Question 7. Here is a number machine. I've got an input of x that passes through the first process, which multiplies it by 3, and then it goes into a second process where 2 is subtracted, and then y comes out the other end. So work out the output when the input is 4. So if I feed 4 into this function machine, the first thing that's going to happen is it's multiplied by 3, and 4 times 3 is 12. Then it's going to pass into the next process, the subtract 2 process. 12 subtract 2 is 10, so that is what then pops out the other end and becomes y then. Okay, so what is the answer? It is 10. Okay. Now the next part says work out the output when the input is -4. Okay, so when we input -4, then, sorry, -4, -4 times 3 is going to be -12, and then subtracting 2 from -12 is going to be -14. So we're going to get -14 come out. So answer is -14. Question 8. Here is some information about the goals scored in some hockey games. Each game has 4 quarters. So we can see there's the first, second, third, fourth quarter on display. The darker bars are home goals and the lighter bars are away goals. Which court has the mode for the away goals? So mode is most, and the light bars are the away goals. So the light bar is going to be the modal quarter for away goals. So that's that second quarter there. Okay, so second quarter. There were 10 games. Work out the mean number of goals per game. Okay, so to work out the mean, we need to know the total amount of goals scored. And then we need to add all those up and then divide by the number of games, which is 10. Okay, so how many have we got? We've got 4 there, 2 there, 4 and 8 and 8 and 7 and 9 and 5. So we're going to have to add all those together. So 4 plus 2 plus 4 plus 8 plus 8 plus 7 plus 9 plus 5. So that's 4, 6, 10, 18, 26, 33, 42, 47. So it adds up to 47. So then the mean is going to be those 47 goals divided by 10, which is 4.7 goals. Okay, it might just be worth double checking that you've added those up correctly, or you could use a calculator just to be sure. In part C, it says in total how many more home goals were scored than away goals. Okay, so in total how many more home goals were scored than away goals? So we added up all of these before, didn't we? So the home goals were the darker bars, so those, and the away goals are the lighter bars. So the home goals added up to 4, 8, 16, 25, and the away goals were 2, 8, 7, and 5, which is 10, 17, 22. So we've got 25, oops, so we've got 25 home goals. And away goals, I made that 22, and then subtracting then gives me 3. So there were 3 more home goals than away goals. 3. Keeps going, this question. 8D. Rob says more home teams must have won because there were more home goals. Is he correct? Give a reason for your answer. Now it could be that in one home game, the home team scored lots and lots and lots of goals, but then didn't score any in its remaining games. So it's not necessarily true just because they scored more home goals, then more home teams won. So I'm going to say no. The home team could have scored many goals in one game and none in the others. It's possible, isn't it? Question 9a. List all the factors of 30. Okay, now when I find factors, I like to start with either ends and then work to the middle. So I will start writing these down in pairs, starting from with 1 and 30. So 1 times 30 is 30. Now I'm going to try 2. Does 2 divide 30? Yes, it does. 2 times 15. 3. Does 3 divide 30? Yes, it does. 3 goes with 10. Try 4. Does 4 divide 30? Nope. Try 5. Does 5 divide 30? Yes, it does. 5 times 6 is 30. Now you notice now we've kind of met up with the numbers coming down the other end. So I'm pretty confident that we've found all the pairs. So the pairs are then 1, 2, 3, 5, 6, 10, 15 and 30. Part B says a factor of 30 is chosen at random. What is the probability that it's a 2-digit number? Okay, so probability is defined to be successful outcomes divided by total outcomes. So we just worked out all the factors of 30 and we found that there were 8 altogether. So there are 8 possible factors that you could pick. Now, how many of those factors have got 2 digits? Okay, well, it's 10, 15, and 30, those 3. So there would be 3 successful outcomes out of a total of 8 outcomes. So the probability is 3/8. Question 10. Each shape below has an area of 24 centimeters squared. Complete the missing lengths. Okay, so we know that area of a rectangle is length times width, and we know that that's going to be equal to 24 then. Okay, so we've been given the length of this, it's 6. What we want to know is the width, isn't it? So 6 times what is 24? Well, it must be 4, mustn't it? 6 4s are 24, so the width is 4. Okay, next up we've got a triangle. Now the area of a triangle is given as half times the base times the height, and we're told that that is again 24, so 24 is equal to half times the baseline, which we don't know, times the height of 16. Okay, so half of 16 is 8. So 24 must be 8 times the base then. 8 times what is 24? 8 times 3 is 24. So that has got to be 24 is equal to 8 times 3. So our baseline there is 3. So 3 times 16 is 48 divided by 2 is 24. Question 11. A television channel shows 12 minutes of adverts in each half an hour. How many minutes of adverts does it show from 5 AM up to 11 PM? Okay, so on the clock, 5 o'clock is down here. So if we count around from 5 o'clock up to midday, then that is going to be 7 hours plus all the way around to 11 o'clock again. That's going to be another 11 hours. That's going to give me 18 hours altogether. So 18 hours at and how many minutes we've got each hour? We've got 12 minutes, haven't we? 12 minutes per hour. So multiplying those together should give us a total number of minutes then, shouldn't it? So 18 times 12. 10 18s, 180. 2 18s are 36. Give me a total of 216 minutes. Or you can type it into the calculator if you like. 216. Question 12. Put these probabilities in order, starting with the least likely. Now we've got a lot of mixed units here, so we've got percentages, we've got fractions, and we've got decimal numbers here. To compare them, it's probably best to put them all into the same sort. 44% I know as a decimal straight away, that's 0.44. A quarter I know straight away. You should know your kind of common fractions, what their decimal equivalents are. Quarter is equivalent to 0.25. That one is already in a fraction, as a decimal, so all I need to do is then convert 4/10. Again, that's 0.4. Now that one has 3 decimal places, so if I just add a 0 onto each of these so they are the same kind of size, it makes them a little bit easier to compare, doesn't it? So I can see then that my smallest is going to be the 0.250 or a quarter. So I'm going to write that one at the beginning. That's the least likely, it's the smallest fraction. The next biggest one then is my 0.400 or 4/10. That's going to come next. Next in size is the 0.404. And finally I've got my 44%. I notice when I wrote them down, I wrote them back in the same units they were to start with. Because that was the form they gave them to me, that's the form I'm going to give them back as their answer. Question 13. A circle is drawn on a centimetre grid. 13a says, draw a tangent to the circle. Now a tangent is a straight line just touching the circle, and we can draw one on using a ruler. So if I pull up my ruler, if you put your ruler so it just touches the circle and then draw your line on, that will be your tangent. So it's a straight line just touching the circle like that. Okay, it doesn't have to be straight up, it can be any, it could be that line or that one over there. Any straight line that's just touching the circle like that is going to be the tangent. Okay, part B says Grace works out the area of the circle. Grace works out that the area of the circle is more than 9 centimeters squared. Why must she be wrong? Well, let's have a look at that diagram. 9 centimeters squared is the same as the area of a square of side 3, because 3 times 3 is 9. So the area of that square I've just drawn around the circle, 3 times 3 is going to be 9, isn't it? And we can see clearly that the circle is smaller than the square. So the area of the circle can't possibly be more than 9. So that's what I'm going to write down. The circle sits inside, can't write inside, let's try that again, inside a square of side 3 and area 9, so it cannot have an area greater than 9. Okay, so the circle sits inside a square of side 3 and area 9, so it cannot have an area greater than 9. Question 14a. The front elevation, side elevation and plan of a solid are all the same as shown. So they're all a square. Write down the name of the solid. Okay, so we're seeing it here from the front elevation. Now if we were looking at it from the side elevation and it was also a square, and the plan view is looking down from above, isn't it? And if that was also a square, then the shape we're looking at is then a cube, isn't it? So it is a cube. 14b says the front elevation, side elevation and plan of a solid are shown are all the same as shown. Write down the name of that solid. Okay, so if it's looking circular from both the front, the side and the top, then I think that shape, I'm not going to draw it, but is a sphere. It's going to have to be a sphere. Question 15. Show that there are exactly 5 3-digit cube numbers. Now, I would recommend for your exam that you remember the first few cube numbers, probably up to 10, but certainly the first 5. 1 cubed is 1, 2 cubed is 2 times 2 times 2, which is 8. 3 cubed is 27, 4 cubed is 64, and 5 cubed is 125. Now you'll notice these first 4 are less than 100, so they're all 2-digit numbers, aren't they? So these aren't the ones we want. We don't need those. This first one, the first cube number that has got 3 digits is 5 cubed, is 125. Okay, so can we work out the other cube numbers? 6 cubed, well, we've got a calculator. This is a calculator paper, so we can use the cube button on our calculator to work all these out. So 6 cubed, there's a cube button there. 6 cubed is 216. 7 cubed is 343. 8 cubed is 512. Okay, what's 9 cubed then? 9 cubed, 729. And 10 cubed, well I know 10 cubed, 10 times 10 times 10 is 1,000. Now again, 1,000 has got 4 digits, so all the ones after that are going to be no good as well. So the numbers that I'm after that have a cube, which is a 3-digit number, are these. Okay, so it's 5 cubed to 9 cubed. So I found them all. So I've shown 5 cubes. Question 16. Triangles A, B, and C and D, E, F are similar. And we've got them shown here. Now it says work out the value of x. Now, if two shapes are similar, it means their sides are in the same ratio. So these two sides match up on my diagram. And these two sides match up. And if we have a look at the relationship between 3 and 6, that's times 2, isn't it? So the 6 is twice as big as the 3. So it's got to be the same here from here to here. It's got to be times 2 as well. So whatever x is, when I multiply it by 2, I'm going to get 9. In other words, x is 9 divided by 2, which is 4.5. Okay, so that's my value of x, it's 4.5. And then it says write down the size of angle y. Well, as well as all the sides being the same ratio, in similar shapes, all the matching angles are going to be the same. So that one and that one actually match up, don't they? So I know straight away that y must be the same angle. It must also be 53. So that needs to be 53 degrees. Question 17. CD and PQ are lines of length 12 centimeters. And we're told that the ratio of CE to CD is 1 to 2. Mark point E on the line with a cross. Okay, CD and PQ are both lines of length 12. Okay, so here's CD. PQ is a bit further down on the page, so this is 12. And actually you've got the 12 digits on here, haven't you? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So it's been already marked up into 12 sections. So if we're told that the ratio of CE to CD is in the ratio of 1 to 2, and we know that CD is actually of length 12, well, I can see that 2 times 6 is 12. So this one must be times 6 as well. That should be, CE should be 1 times 6, which is 6 units in length. So mark E on the line with a cross. It's going to be 6 units up from C. 1, 2, 3, 4, 5, 6. It's going to be here. Okay. And then we're told that PR to RQ is in the ratio of 1 to 3. Mark the point R on the line with a cross. So notice R is the one in the middle of these. The ratio for the distance from P to R, the point we need to mark, compared to R to Q, is in the ratio of 1 to 3. So basically we've got to divide up this line in the ratio of 1 to 3 to work out where R is. So it's a bit like one of those questions where you have to divide a number by a given ratio. Add in the two parts of the ratio together. 1 plus 3 is equal to 4. So then if we take the length of our line 12 and divide it by 4, we can see that gives us the answer 3. So that means if we take our original ratio 1 to 3 and I scale it up by a factor of 3, because that's the number I just found here, that's going to give me 3 to 9. Which means my point R is going to be 3 units from P and 9 units from Q. It's going to be that point there. Did I label that one? I should relabel that as well. That's E, that's R. Okay, done. Question 18. A shop sells 2 brands of batteries, brand A and brand B. Brand A comes in packs of 8 and they're priced at £3.60. Brand B comes in packs of 6 and they're priced at £2.94. One brand A batteries powers a toy for 5 hours. One brand B battery powers the same toy for 5.5 hours. Which brand is better value? You must show your working. Okay. Right, so that's quite a tough question. Got lots of things to work out here. Let's start with brand A. Let's divide this in 2 because we're going to do a similar calculation for both, aren't we? So I'm going to divide up my page into 2, and then this can be my brand A side and this can be my brand B side. Okay, so first off, These brand A comes in packs of 8 and they last for 5 hours. So then the total hours of charge you get for brand A is going to be 8, the number of batteries, times 5, the length that each battery lasts. So that pack is going to give me 8 times 5 or 40 hours of toy fun, isn't it, before it all runs down. Now brand B, I'm going to do the same calculation. So total hours here, how many batteries have I got? I've got 6 in that pack and they last for 5.5 hours. So 5.5, 6 times 5.5. If you're not sure, you could do it on a calculator. I'm going to double it. So 5.5 times 2 is 11 and then times it by 3, which gives me 33. Or you can put it into a calculator. So brand B, you've got less batteries. Each one lasts longer, but because we've got less batteries, it lasts for less amount of time altogether. Okay, so brand A is obviously going to last longer, but also brand A is more expensive. It's £3.60 for a pack of 8, and the other one is £2.94. So I'm going to see if I can work out what the cost is of each hour then. Okay. So we've got something useful to compare. If I take the cost, it's £3.60, and divide it by the number of hours, 40, I'll be able to work out the cost of 1 hour. So the cost per hour of brand A is going to be the cost, £3.60, divided by the 40 hours that it lasts. So, putting up the calculator, £3.60 divided by 40 hours. That comes out to be 0.09 or 9 pence. So that's going to cost 9 pence per hour of fun that you have with your toy there. Let's have a look at the other one. Cost per hour. Now, these batteries cost £2.94. So 2.94, and they lasted for 33 hours. So dividing £2.94 by 33 will give me the cost per hour of these batteries. So £2.94 divided by 33, that comes out to be 0.089, which is just fractionally under, well, it's 89 reoccurring. So it's just ever so slightly under 9 pence. Okay, probably rounds up actually, but I'm going to leave it like that because it is a slither under the other one. There's not a lot in it actually. They're very similar in price, but I would say that brand B is slightly better value because the cost of every hour is slightly less than brand A. So I'm going to say brand B is the best value. Now, if you were using my walkthrough as a mark scheme, there are lots of different ways that you can do this. As long as you've got 2 things that you can directly compare between brand A and brand B, yeah, you can still get all the credit for this answer, but that seems a logical way of approaching it to me. Question 19. The value of x can be 2 or 5 and the value of y can be 3 or 12. List the possible values of x and y. Okay, or x times y. I'm going to quickly show you this in a possibility space. So x, the values of x up here, they can be 2 or 5. And the values of y can be 3 or 12. So that gives us 4 possibilities, doesn't it? Multiplying them together in 4 different ways. 3 times 2 is 6. 3 times 5 is 15. 2 times 12 is 24. And 5 times 12 is 60. So there are my possible values then. 6, 15, 24, and 60. Question 19b says, work out the least possible value of x minus y divided by x. You must show your working. Okay, so I'm going to take a similar approach to last time with the possibility space. So I've got 2, 5 and 3 and 12 as my possible answers. So 2, 5, 3 and 12. And I'm going to work out what the fraction is for each of those possibilities. So this was my x value and these are my y values down here. So in this first cell here, that's the one with x is equal to 2 and y is 3. So that would give me 2 subtract 3 over 2, which is equal to minus a half. Okay, now the next box along would be 5 subtract 3 divided by 5. What's that then? 5 subtract 3 is 2, that would be 2/5. The next box along would be 2 subtract 12 divided by 2. 2 subtract 12 is minus 10 divided by 2 is minus 5. And then finally, 5 subtract 12 divided by 5. 5 subtract 12 is minus 7, so that would be minus 7/5. Okay, so which one would be the least, the smallest? Now, one of them is positive and 3 of them are negative, so all the negative ones are less than that one, so it's definitely not 2/5. So which is the smallest value out of -1/2, -5 and -7/5? Well, -7/5, 5 goes into 7 once, so that's the same thing as -1 and 2/5, isn't it? Or -1.4. So I think the least one is going to be this one here, the most negative one. It's going to be -5. Okay, so it's that one there. Question 20, an exam paper has 2 papers. Anil scores 33 out of 60 on paper 1 and 75 out of 100 on paper 2. Work out his percentage score for the exam. Okay, so his overall percentage is going to be his overall score, which is the 2 marks added together, his 33 and the 75, divided by the total marks available for the 2 papers, which was 60 and 100, and then turn that into percentage. Okay, so what's 33 and 75? We can just do that on a calculator actually. So 33 plus 75 over 60 plus 100. Now that comes out to be 0.675, which as a percentage is 67.5%. Purple paint is made by mixing red paint and blue paint in a ratio of 5:2. Jan has 30 litres of red paint and 9 litres of blue paint. What is the maximum amount of purple paint she can make? Okay, so the ratio of red to blue is, well, it needs to be 5:2. Okay, so if I increase this ratio, so I increase the amount of red paint required from 5 to 30, I would be multiplying through this ratio by a factor of 6. So I'd have to do the same this side, which means for 30 litres of red paint I would require 12 litres of blue paint, but I don't have 12 litres of blue paint, I've only got 9, so that is not possible. So the best I'm going to be able to do is to make blue equal to 9. So what do I have to multiply 2 to get 9? I have to multiply it by 4.5, don't I? It's 4.5 times bigger. So if I multiply 5 by 4.5, it means, what's that? 5 lots of 4.5, 9, 18, 22.5 litres of red paint. So what's the maximum amount of purple paint that she can have? Well, I suppose when you add 22.5 litres of red paint to 9 litres of blue paint, then altogether you're going to have 22.5 plus 9 litres of paint, which is 31.5 litres So she's going to have 31.5 litres of purple paint. This shape is made from 2 triangles and 4 congruent parallelograms. For each statement, tick the correct box. The triangles are equilaterals. Right. We don't know anything about the angles here, but I assume if this one here happened to be 120, then this one would be 60. And because these are parallelograms and they're all identical, that one would also be 120, so this one must be 60, so this must be 60. So in that case, it could be that the triangles are equilateral. But however, if the angle wasn't 120, and there are lots of other possibilities for it to be, then it wouldn't be. So it could be true, but it's not must be, and it's not must be false either. Right, the triangles are congruent. Okay, well, whatever that angle happens to be, 120 or anything else, it's going to be the same on the triangle below, isn't it? So whatever this angle is here, then so is this one, and so is this one, and so is this one. So that means the angles here and here and here and here are going to be the same, in which case this one and this one are going to be the same. So yes, whatever the angles happen to be, they're going to be congruent. So I'm going to go with must be true. Question 7a. The length of a pipe is 6 meters to the nearest meter. Complete the error interval for the length of pipe. Okay, well, if it's 6 to the nearest meter, then the next one up on the scale would be 7, and the one below it would be 5. And the ones closest to 6 then would round to 6. So the ones in here. Okay, so where does the boundary lie? Halfway between the two of them, 5.5 and 6.5. So we want our length to be greater than or equal to 5.5 and less than 6.5. Okay. Question 7b says the length of a different pipe is 4 meters to the nearest meter. Ollie says the total length of the 2 pipes is 11 meters to the nearest meter. Give an example to show how he could be correct. Well, we know that the first pipe is between 5.5 and 6.5. So let's say if one pipe is up towards the upper end of that range, 6.4, and the other is, well, it could be 4.4, couldn't it? So then 6.4 plus 4.4 is 10.8, which is closer to 11 than 10, isn't it? So yeah, it could be 11 to, what's that, 2 significant figures. Okay, so he's right. A, B, C, D, and E, F are straight lines. Yes, they are. Ava assumes that A, B, and C, D are parallel. What answer should she get for the size of Y? So if A, B, and C, D are parallel, so this one is parallel to this, then what should she get for angle Y? Well, if they were parallel, then this angle here and this one up here are going to be corresponding, aren't they? And therefore they're equal. So 2x plus 10 is going to be equal to 3x minus 2. So we can use that fact to form an equation in x that we can go on to solve. So 2x plus 10 is equal to 3x minus 20. So I'm going to click the x's on the right hand side to keep my x's positive. If I take x to the other side, I'll get a negative value, so I'm not going to do that. And I'm going to move that over here to keep that positive as well. So that's going to give me 10 plus 20 is 30, and 3x take away 2x is x. That would give me x is equal to 30. So if x is 30, then our congruent angle then is going to be 3x minus 20 is going to be 3 lots of 30 minus 20. 3 lots of 30 is 90, take away 20 is 70. So then this angle up here then must be 70, and so y is going to be 180 minus 70, because they lie in a straight line, giving you a value of y of 110. So 110 if her assumption is correct. 10b says, in fact, A, B and CD are not parallel. Angle W is 60. What effect does this have on the size of angle Y? Okay. Right, so if these if these lines are no longer parallel, let's take those little arrows off, because that no longer holds. Then W is 60. Let's write in a different color pen so it's different from my working from before. So if this is 60 degrees, then so is this angle over here, because it's vertically opposite. So 2x plus 10 is equal to 60. So 2x plus 10 equals 60. So that makes 2x equal to 50, x equals 25. Okay, so if x is 25, then 3x minus 20, 3x minus 20 is equal to 3 lots of 25 minus 20. 3 25s is 75, take away 20 is 55. So that angle is going to get smaller from 70, what we thought it was before. It's now going down to 55. Okay, so if that angle decreases from 70 to 55, it's dropping by 15, then my angle Y is going to increase by 15. That's going to go up to 125 then, isn't it? Okay, because those two angles are still going to have to add up to 180. So we're saying Y is increasing, and I've got the working here on the diagram, but maybe the marker doesn't see it up there. I think it's probably fine, but just on the safe side, you might want to copy that over into the answer box below. So we said 2x plus 10 is 60, so Y is bigger. We said that 2x plus 10 was equal to 60, which implied that x was equal to 25. So then we worked out the next part. We said 3x minus 20. So 3x minus 20 was 55. Not 70. So 3x minus 20 has decreased by 15. So y will increase by 15 to 125. Question 9. There are 720 boys and 700 girls in a school. The probability that a boy is chosen at random studies French is 2/3. The probability that a girl chosen at random studies French is 3/5. Work out the number of students who in the school who study French. Okay, well then we know that the probability of boys studying French is equal to 2/3, and that must have been obtained by dividing successful outcomes divided by total outcomes. Now we know that the total outcomes are 720 because there are 720 boys, and 3 times something is 720. 720 divided by 3 is 240, so times in that by 240 and times in that by 240 would tell me that there must be 480 boys studying French. What about the girls? Probability that a girl studies French. That's equal to 3/5. And we know that the total number of outcomes for girls was 700. And how many times does 5 go into 700? 5 goes into 700 140 times. So multiplying 3 by 140, 140, 280, 380, 420. So there must be 480 boys studying French and 420 girls. So in total, it's 480 plus 420, which is 900. 900 students. Question 9b says, work out the probability that a student chosen at random from the whole school does not study French. Well, we know how many students study French now. So the probability of not French is going to be 1 minus the probability that they study French, which is 1 minus, well, we know that there are 900 students altogether, of which, no, sorry, we know that there are 900 students who study French, and we know that there are 720 plus 700 students altogether, so that's up 1420. So that must be 520 over 1420, just subtracting one fraction from that fraction from 1. That is a probability. I don't think I need to cancel it down. You don't get any extra credit normally for cancelling down fractions in probability questions, so I'm just tempted to leave it like that, although you do have a calculator that can cancel down fractions for you, so perhaps there's no harm in doing it this time, which is 26 over 71. But like I say, if you've secured all the marks to this point here, then the only thing that can happen if you then go on and simplify it is that you still get 2 marks. That's the upside. The downside is if you make a mistake in this cancellation and you write it down incorrectly, you will then lose that accuracy mark. So like I say, the only possible extra thing that can happen if you cancel down a fraction as an answer percentage question is that you can lose a mark. So perhaps you should just leave it like that and play safe. Question 26. Circle the expression equivalent to x squared minus 4x minus 12. And we've got a few double brackets multiplied together. So clearly we need to factorize this expression. When we factorize a quadratic, we look at the first term first to work out what goes at the beginning of our brackets. So something times something is x squared. It must be x and x. Okay, next thing we need to do is look at the number on the end and think about what factor pairs multiplied together to give you minus 12. Well, you could have minus 1 and 12, or 1 and minus 12, or we could have negative 2 and 6, or the other way around, 2 and minus 6, or we could have negative 3 and 4, or the other way around, 3 and negative 4. So then it's a matter of working out which pair of those is going to deliver us this negative 4 in the middle. So which pairs of these numbers add up to negative 4? And with a little bit of trial and error, you should find out that it's this pair here. 2 subtract minus 6 is negative 4. So my solution is going to be x plus 2, x minus 6, which is that one there. How are the whole number solutions of A and B different? We've got A, which is solve 3 is less than or equal to 3x, which is less than 18, and B, which has 3 is less than 3x, which is less than or equal to 18. Okay, now notice everything there is a multiple of 3, so I can simplify both expressions by dividing everything through by a factor of 3. That tells me 1 is less than or equal to x, which is less than 6, and B gives me 1 is less than x, which is less than or equal to 6. Okay, so the values of x which satisfy A are going to be the values 1, 2, 3, 4 and 5, and the values of x that satisfy B are the numbers 2, 3, 4, 5 and 6, because the endpoints are slightly different, aren't they? Okay, so what's different about them? So I'm going to say A contains 1 but not 6, and B contains 6 but not 1. Okay, probably overkill, but I've covered everything now. So that's all. We've reached the end of the paper. How did you do? Let me know in the comments below, along with any questions you still might have. Don't forget to like and subscribe if you found this walkthrough helpful. If you didn't do so well, try revising around the topics you're struggling with before attempting another past paper. Good luck with your preparations and in your exams, and see you again next time.